Okay. Electric field, electric field due to due to a charged due to a charged straight wire. So due to a charged straight wire. So we have to derive the electric field due to charged straight wire using Gauss's law. So what does the Gauss law state? That the flux is equal to 1 by epsilon naught times the charge enclosed in it, is the Gauss law statement. So let us consider a infinitely, so let us consider infinitely. So this you have done in your class 12 also. So again I'm just doing, consider long straight wire. Let us consider infinitely long straight wire. Okay. uh, okay, let us consider infinitely long straight wire having line charge density lambda. Okay, let us just consider a point p which is at a distance a from straight line charge, which is at a distance a from a straight line charge. Okay, so now the direct here, let me consider that a long straight conductor. Okay, so here if I just consider a Gaussian sphere, so the Gaussian sphere, it will be cylindrical in shape, and that height of that Gaussian sphere is h, that is a cylinder. So now let us consider a point p where the electric field will be radially outwards, and I just consider that the point p is at a distance a from the center. So now the electric field, that is, let me consider this as a small sphere ds here. Okay, so this is a phase a, phase b, and this is c. Now the electric field, as I said that electric field ಏನಾಗಿರುತ್ತೆ, it will be radially outwards. So the electric field will be radially outward due to the symmetry. So now, by assuming all these, so charge, now let us consider that p is at a distance where distance a from the center of the straight line, and electric field we have assumed that it is radially outward due to the symmetry. Now if we consider these assumptions and just draw the Gaussian sphere, it looks like this. Gaussian cylinder, it looks like for a straight uniformly charged conductor. Okay, so now let us, as I said that, let me name that as a and b, c. Okay, so a and b are normal to the A and B are normal to the axis. Okay, so A and B are normal to the axis which represents the Gaussian surface. Okay, now let us consider a small area ds on a Gaussian surface. Okay, on the surface A. First, let me consider a small surface on the ds here. Okay, ds. So now this area, this area acts along the outward drawn normal, and its right angles to the electric field. So now here we know that the electric flux is given by, it is integral of E dot ds. So here the flux, it is, as I said, that the flux will be acting radially outwards. ನಾನು A ಮತ್ತೆ C ಅಲ್ಲಿ ನಾನು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, so it is the flux, whatever the flux it is going here, it acts like this. So now we know that E ds cos 90, because it is 90 degrees. So we know that cos 90 is equal to 0. The flux will be at right angles in the shape radially outwards, which are normal to face A. It will be 0 in this direction. Flux ಹೋಗೋದು ಎಷ್ಟಿರುತ್ತೆ, the flux will be 0 in this direction. Similarly, this is for a surface A. So surface A ಇಂದ ಹೋಗುವಂತ flux ಎಷ್ಟಿರುತ್ತೆ, this is almost 0. So similarly, flux for surface B. For surface B will be how much? So similarly, it is also because phi E dot ds is equal to E ds cos 90 is equal to, because cos 90 is equal to how much? It is 0. So phi E dot ds is equal to, phi is equal to 0 for the surface B. Now the important face is, that is surface is C. Let me just consider the C. For the surface C, for the surface C, the area vector ds and the electric field E are parallel to. So earlier case ಅಲ್ಲಿ ಏನಿತ್ತು, for A and B, the area vector ds and the electric field E are normal to each other, ಅಂದ್ರೆ perpendicular ಆಗಿತ್ತು. So perpendicular ಆಗಿದ್ದಾಗ, so your flux will be 0. Here it is not perpendicular for the surface C, they are electric field and the area vector ds are parallel to each other. So what I can just consider is parallel, and one more thing is that, and in the same direction. So same directional ಇರೋದ್ರಿಂದ I can just consider C is E dot ds is equal to flux E ds cos 0. Cos 0 is nothing but 1. So it becomes E ds. Okay, E ds. So now, as all points on the curved C are equidistant, you can see here, as all points in the curved sphere are equidistant from the axis, the electric field is same everywhere. Therefore I can just consider that here electric field is constant here. So electric field at A is constant, so that is E ds is equal to, it is E ds, which is equal to, so this cylinder area will be, the surface area of a cylinder is 2 pi a. Okay, so E is outside, the surface area is nothing but 2 pi a h. So that's why the flux will be phi is equal to 2 pi a h E. So, okay, so what is this 2 pi ah? Is nothing but area of curved surface area of cylinder. Curved surface area of a cylinder, which is equidistant from the axis. So now, according to the Gauss law, the electric flux of a closed surface is equal to phi E is equal to E ds double integral is equal to E dot ds. Let me just take it. So flux due to the surface A E dot ds plus flux due to the surface B E dot ds plus flux due to the surface C E dot ds. So now I can just write it, which is equal to Q by epsilon naught. So now I can just write it. So the total charge, we know that the total charge within the Gaussian sphere is equal to charge on the wire. As I said that the height of this wire is h ಅನ್ಕೊಂಡ್ರೆ, so linear charge density lambda into h. Linear charge density ಇರೋದ್ರಿಂದ lambda into h. So the flux is equal to phi E dot ds is equal to lambda h by epsilon naught. So let me just consider that it is equation number 2. ಇಲ್ಲಿರೋದನ್ನ equation number 1 ಅನ್ಕೊಂಡ್ರೆ, that becomes 2 pi. This is equation number 1 ಅನ್ಕೊಂಡ್ರೆ and this is equation number 2 ಅನ್ಕೊಂಡ್ರೆ, if I just consider that 2 pi ah into E is equal to lambda by epsilon naught, or E is equal to 1 by 2 pi 1 by 2 pi epsilon lambda h. Okay, h gets cancelled. Lam 2 pi epsilon naught lambda by E. Clear? So to find the what is our aim? Our aim is to find electric field due to the charged straight wire. So charged straight wire ಅಂತ ಹೇಳಿದ್ರೆ, so first what is the assumption ಅಂತ ಹೇಳಿದ್ರೆ, first our assumption is that, so here electric field is radially outwards ಇದೆ ಅಂತ ಅನ್ಕೊಂಡಿದೀವಿ. And then if we construct a Gaussian sphere and we consider the small surface ds, and we consider the electric field at that electric flux going out at the surface A and surface B and surface C. So electric flux going at the surface ಏನಾಗುತ್ತೆ, because surface A E and ds are perpendicular to each other. So perpendicular to each other ಇರೋದ್ರಿಂದ, so flux due to the surface A and surface B, it will be 0. What we have to consider? We have to consider flux only at the surface ds. So surface ds signal surface ds for on the face C. So for that, what I have just considered is E dot ds, that is eds cos 0. So eds cos 0 is nothing but 1. So eds. So now if I just consider that it is in the shape of curved surface area of a cylinder, 2 pi ah anta tagoltini, where a is the radius, h is the height of the cylinder. So what happens? Your flux will be pi is equal to 2 pi ah e baratte. So now total flux is equal to E dot ds of surface A, E dot ds of surface B, E dot ds of surface C is equal to, now that is, now it becomes now A and B are 0. So the third one is 2 pi ah into E is equal to Q by epsilon naught. So now to find the charge density, the total charge Q is equal to lambda h. So it becomes lambda h by epsilon naught. So let me make that as equation number 2, and this one 2 pi ah as equation number 1. Just compare those two. It becomes h gets cancelled. E is equal to 1 by 2 pi epsilon naught lambda by A. Is that clear? So the electric field due to the straight charge conductor is equal to 1 by 2 pi epsilon naught lambda by A. Okay, lambda by A. Sure, ಬರ್ತೀನಿ ಖಂಡಿತ ಅಲ್ಲಿಟ್ಟು ಹೇಳ್ತೀನಿ. ಫೈನ್. ಸೊ ಅರ್ಥ ಆಗಿದೆನಾ? ಇದು ಅರ್ಥ ಆಗಿದೆನಾ?